I suppose in this session I will explain how to develop a slightly complex system with better efficiency to summarize the news article like this and present few sentences like 2 or 3 sentences or as a summary of this news article. For this I will use slightly complex algorithm. This is nearly similar to LEXRank and which uses the modified version of PageRank algorithm. So first of all, I will go through how to define the modified version of PageRank algorithm and how to use it for summarization purpose. First of all, I will explain how simple graph-based PageRank and modified PageRank algorithm is useful in summarizing the documents. So first of all, we consider that this is a simple graph having node S1, S2, S3, S4, S5 and S6. Now in a simple PageRank algorithm, for summarization, you have earlier seen that the link between node S1 and S2 depends upon the occurrence of a common words between both sentences. For example, in S1 and S2 we have two common words W1 and W3, so its link weight is defined as 2. Similarly, between S1 and S3 there is no common word. Between S1 and S4 we have two common words W1 and W2. You can find here W1 and W2. So link weight was 2. Now the problem is actually in sentence S1 where W1 may have different level of importance. So the traditional PageRank based algorithm treats each co-occurring word equally, and it creates if we continue this, then it will be like working with less amount of information. So to remove this drawback, a LEXRank based algorithm was proposed. Here you can find the paper on LEXRank. This is the traditional PageRank algorithm defined to explain the algorithm. And this is the modified version of PageRank algorithm used to rank the sentences in the text documents. So how this algorithm works? So first of all, in traditional PageRank algorithm, suppose you are going to calculate the PageRank algorithm of word S1. So in this case, in traditional algorithm, the PageRank score of S1 will be calculated like Here n is equal to 6, total number of nodes are 6, so n will be equal to 6 plus d into adjacent nodes are node S2 and S4, so it will be equal to page rank score of node S2 divided by its degree plus page rank score of node S4 divided by its degree. So this is the traditional calculation of page rank algorithm by this formula. Now suppose word 1 is highly important in S1 and S2, but word W3 has less important in S1, and this is least important words. So this matching of count 2 is maybe different from this matching count of 2 due to the difference in importance of the word. To capture this, in this equation, IDF-modified cosine similarity score is used. Actually, IDF-modified cosine similarity calculates the cosine similarity between two sentences by using the weight of common words between the sentences. So, in this case, the same page rank score will be into here all adjacent nodes for node U. Here node U is taken as S1, so all adjacent nodes will be like S2 and S4. So here it will be IDF modified cosine similarity between S1 and S2. We can represent IDF modified, we can represent this as a short form like IDFC. So it will be like S1 S2 divided by, instead of using its degree, we identify all the nodes Z which are adjacent to node B. So we will identify all the nodes which are adjacent to node S2. So it will be like this and this. So it will be like sum of IDF S1 S2 plus S2 and S3, as here Z equal to S3 and S1 which are adjacent to node B. Here B is S2. Now if B will be S4, then it will be like S1 S4 divided by actually its degree is 3 here, so it will be like inverse IDF modified cosine similarity of this edge and this edge. So it will be like S1 S4 plus S4 S3 sorry S3 S4. Here it may be same because we are using undirected word graph of text. S5 and S4. So this is the general algorithm to calculate the page rank score of node S1. So this is the difference between calculation of page rank score of by a traditional page rank algorithm, and this is the calculation of page rank algorithm of same node S1 by using IDF-modified cosine similarity score. Now to calculate and know about IDF-modified cosine similarity score, we can use some tutorial like from this is the Java code for calculation of inverse IDF-modified cosine similarity score. Now from this calculation it is clear that why IDF-modified cosine similarity score based text rank performs better than this algorithm. So I will explain this through some code also, but we can fix something like damping factor. Generally we use the damping factor value 0.85 for better performance. To know more about damping factor, actually the PageRank algorithm is based on the random surfer model. Here damping factor works like a decay factor, where it represents the chance that a user will stop clicking links and get bored with a current page and then request another random page. This may be like instead of following the link, it may be like trying directly to a new node rather than clicking the following links. We generally use 0.85 as a damping factor for best performance. Now this is now the next part is how to use this PageRank algorithm to calculate the summary of the documents. Now for this same text we can copy the all text and this is the copied text from the web page. So this is the main summarization. You can see the difference between summarization. The first part of the code, this part represents the traditional summarization with traditional PageRank algorithm as discussed here, and this part of the code represents the summarization using this algorithm. Now you can see the difference, but before going in detail, first of all I will explain how to go for pre-processing step. Actually the pre-processing step separates the sentences. This is the document pre-processing class. It actually uses some OpenNLP tools to identify or extracts the sentences. Here the system works like extracts each sentence and put it in a separate line, and after that I apply a simple cleaning to remove the noisy symbols or some punctuation marks, etc. And after that I had applied Stanford Lemmontizer For that, to get the Stanford Lemmontizer, you have to use Stanford Core NLP tools, and this is the code for Stanford Lemmontizer. And after that, we applied Stanford POS tagger to identify all adjectives and nouns. For example, if we have this sentence, then after pre-processing, we will have all nouns and adjectives only, because it is already proved that instead of using all stop words and other verbs or etc., if we just consider noun and adjective sequence of noun and adjective of sentence, then it gives better performance. Now suppose if we represent this as a sentence S1, then we can demonstrate it like empty may be word W1, seat may be represented as W2, Olympic may be represented as word W3. Similarly, games may be represented as word W14. Rio may be like word W15, and summer may be like word W16, and so on. Similarly, sentence S2, S3, S4 and S5 and S6 can be represented, and then we can use this to prepare word graph. So to prepare the sentence graph of text, where each sentence is treated as a node of the graph. So you can see after this pre-processing step, now first of all I think we should run the system, because it contains so I run the system. The final output will be like target file 2. Now the other part of the system is how to calculate the PageRank algorithm. To calculate the PageRank algorithm, I have used Jung library, Java Universal Network Graph library. You can download the Java Universal Network Graph library from this page. And other important thing is the use of modified cosine similarity score, which is inverse document frequency based modified cosine similarity score. You can find the code here, and for this we need some corpus to calculate the inverse document frequency. For this we use the DBpedia corpus, the standard DBpedia corpus. You can find the DBpedia corpus like this. So this is the standard DBpedia corpus. From here you can download it. Now you can use the source code given in our website. To calculate the indexes for all the DBpedia web page, DBpedia pages. After calculation, the index will look like this. Here we use this index index directory path to calculate the inverse document frequency for the words and use it in the calculation of IDF-modified cosine similarity score of cosine similarity score between two sentences. So now this is the final output, but before going to see the result, we first explain what important libraries should be there. Like other libraries should be there, like okay, we have covered all those libraries, and now we can see the results. So these are the results. This is the pre-processed text. The pre-processing step is already clear that this is the simple sentence, and after pre-processing you can find that it contains only the sequence of noun and adjective. So it first separated all sentences into a separate line, and after that it extracts noun and adjective. Now you can see the summarization. This is a summarization score with a simple PageRank algorithm like this. So according to this, ninth sentence will get the highest score, and then sentence first will get the second highest score. Sentence 10th will get third highest score. But if you go through IDF-modified cosine similarity score based modified PageRank or LEX-Rank algorithm, then you can find that sentence 9th shows the highest score, highest PageRank score. Then second rank, at second rank you can find the sentence first, and at third rank you can find the sentence 6. If you read both summary, then you can find that this summary will give you a better explanation. If you select, suppose you are going to select top 3 sentences to represent the entire document or entire news given here, then in this case the second summarization score, which is calculated by using IDF modified cosine similarity score based PageRank or modified PageRank, you can say it LEXRank also, then it gives a better result. For the summarization, you can get all the code, source code, entire source code and working system from my website. And now in the next session of summarization, I will cover the topics like maximum marginal relevance and update summarization. Thanks.